Ever wonder how an AI really learns? What's actually going on under the hood? It's not some kind of dark magic, I promise. Today, we're going to pull back the curtain and actually build an AI brain right from the ground up. We'll start with the most basic choices and build all the way up to a network that learns, kind of like we do. So, here's our blueprint for building this brain. We're going to kick things off with the one big choice every AI designer has to make. Then, we'll dive into the three main ways an AI can be taught to learn. And finally, we'll peek inside the actual structure that makes it all possible. All right, so first things first. Every single AI starts with one huge fundamental choice. Do you give it a super strict rulebook that it has to follow no matter what? Or do you let it figure things out and learn on its own? This one decision changes absolutely everything. And this slide just nails that difference. On the left, you've got the rulebook AI. Think of it like a really detailed instruction manual. It's rigid. It follows if this, then that commands that a human programmed. But on the right, you have the AI that learns from experience. This one gets to look at a ton of data, spot patterns for itself, and even adapt when new info comes in. It's dynamic. It's alive. Okay, so for the rest of our time here, we're going to focus on that second type, the one that actually learns. And the most common way it does that is called supervised learning. The best way to think about it, it's like a teacher showing a student flashcards where the correct answer is already written on the back of every single card. The secret sauce for this type of learning is something called labeled data. And, well, it's pretty much exactly what it sounds like. It's a massive data set where every single piece of information already has the correct answer tag to it. You're basically giving the AI a giant cheat sheet to study from, like thousands of photos all neatly labeled cat or dog. And here's how that process actually works. Step 1, you just feed the machine all that perfectly labeled data. Step 2 is where the thinking starts. The model just turns through all those examples, trying to find patterns. What pixels, what shapes, what features always seem to pop up when a label says dog. Then, in step 3, you give it the final exam, a brand new picture it has never seen before, and see if it can predict the right label. You actually interact with this teacher-led learning all the time. Your email spam filter, it learned by studying millions of emails that humans had already marked as spam or not spam. And when a social media app magically recognizes your friend in a photo, it's because it learned from all the pictures that were already tagged with their name. So the crucial point is, it's all about learning from known answers to figure out the unknown ones. Okay, but what if there are no labels? What if all you have is this massive, messy, chaotic pile of data? Well, that brings us to our next style, unsupervised learning. With this one, the AI isn't a student with an answer key anymore. It's more like a detective dropped into a brand new world with no instructions and just told to make sense of it all. Its whole mission, really, is to create order out of chaos. It has to sift through this absolute jumble of raw, unlabeled information and just start grouping similar things together. It's looking for hidden connections that we, as humans, might not even see ourselves. It usually does this in a couple of main ways. First up is clustering. This is just about grouping similar stuff together. Think of a big online retailer. They could use this to find groups of customers who shop in similar ways without ever giving those groups names. The other big one is association. This is all about finding those peanut butter and jelly relationships. It's how a grocery store discovers that, hey, people who buy bread are also extremely likely to buy butter. And this is where it gets really powerful. Because the AI doesn't have our human biases, it can find connections that we would never, ever think of. It can uncover genuinely new insights that were just sitting there, hidden in the data. All right, on to our third learning style. This one's all about good old-fashioned trial and error. It's called reinforcement learning. And honestly, the best way to think about it is like training a pet with treats or how you get better at a video game. You try something, you see what happens, and you adjust your strategy based on whether you got a good result or a bad one. So here's the first half of that loop. The AI is shown a picture of an apple, and it takes a wild guess, cherry. Wrong. The system immediately gives it negative feedback, a penalty. It's like a little note to itself that says, nope, that action was bad, don't do that again. So on the next try, having learned from its mistake, maybe it guesses apple. Ding, 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 correct! And this time it gets positive feedback, a reward. That action gets reinforced. Its little AI brain learns, aha, doing that gets me a point. I should do that more often. And you just repeat that tiny loop millions, maybe billions of times. The AI's one and only goal becomes incredibly simple: maximize the total reward. This is so powerful for things in complex, changing worlds, like a self-driving car navigating traffic, or an AI mastering a video game. You can't just give it a static data set. It has to learn and adapt on the fly. Okay, so we've covered the how. We've seen that an AI can learn with a teacher, like an explorer, or through trial and error. But what is the actual machinery, the brain itself that lets all this learning happen? Well, that brings us to artificial neural networks. An artificial neural network, or ANN for short, is a system that is literally modeled on our own brains. It's built from tons of these little interconnected nodes, which are kind of like our neurons, all organized in layers. This special structure is what allows it to process insane amounts of information and, this is the key part, automatically figure out which parts of that data are the most important. And the way information flows through it is pretty logical. First, the input layer just gathers up all the raw data, all the basic questions. Then that info gets passed to the hidden layers. Now, this is where the real thinking happens. Each node in these layers weighs the importance of all the different inputs. And finally, all that processing comes together in the output layer, which spits out the final answer. Now that might sound a little abstract, so let's make it totally concrete with a simple human decision. Should I go to the park? This table is a perfect simplified look at how one of those nodes thinks. We've got our inputs, and we turn our answers into numbers, like yes is 1 and no is 0. But that last column, importance or weight, that is everything. The network learns that the current sunny weather is the most important factor, so it gets a high weight, a 0.4. But having an umbrella? Less important, so it only gets a 0.1. The AI then combines all these weighted inputs to make its final call. And this right here is the crucial point that ties everything we've talked about together. The actual learning is the process of adjusting these weights. If the network makes a bad decision, it goes back and tweaks the numbers. Maybe it gives the weather forecast a little more importance next time. And through thousands and thousands of these tiny adjustments, it fine-tunes itself and gets smarter over time. So let's just do a quick recap. We've built our AI brain, and we've seen the 3 fundamental ways it can learn. There's supervised, where it's like a student with a perfect answer key. There's unsupervised, where it's an explorer finding hidden patterns all by itself. And there's reinforcement, where it's a player learning from the consequences of its actions. So this really leaves us with a final thought. We have figured out how to give machines these incredibly powerful ways to learn, like a student, an explorer, or a master strategist. The question isn't just how they learn anymore. The real question is, what massive, complex, world-changing problems are we going to ask them to solve next?